Today's goal is to decide which operations, that is, if we're adding, subtracting, multiplying, or dividing, or maybe using exponents or square roots, things like that, which operations require common denominators. I'm going to tell you a story about my family. Let's suppose that when I was young, we went trick-or-treating out in the country. The first house gives each of us 2 pieces of candy. So I get 2 pieces of candy in my really cool Halloween pouch. My little brother gets 2 pieces of candy. My sister gets 2 pieces of candy. How many pieces of candy do we have in total? Well, we can count 1, 2, 3, 4, 5, 6. We'll have 6. So here's my graphic picture. Algebraically, this would be 3 groups of 2 pieces of candy is 6. Okay, well, at the next house, we each get half of a Hershey bar. Okay, so I get half of a Hershey bar. My brother gets half of a Hershey bar. My sister gets half of a Hershey bar. How many total Hershey bars do we have in total? Well, 1/2 and 1/2. This would make up a whole Hershey bar plus an extra half. So in total, we have 1½ Hershey bars. And algebraically, that would look like 1/2 plus 1/2 plus 1/2 is 1½ Hershey bars. Or you could say it would be 3 people who each get half a Hershey bar, gives you 1½ total Hershey bars. Interesting. Okay, exhausted because we're in the country, houses are really far apart, so we only went to 2 maybe. We went home, and this is a picture of my mom and dad, and they were hungry, so they also want candy. So how many pieces do we each get? Well, we got 6 pieces of candy from the first house and a piece and a half from the second house, so that gives us 7½ total pieces. 7½ is more than 5, so let's give everyone a full piece. Here's 1 for me, here's 1 for my brother, 1 for my dad, 1 for my mom, 1 for my sister. Okay, that would be 5 pieces. I have 2½ pieces left. Not enough to give everyone a full piece. Here's our full piece of candy. Well, let's try giving everyone a half. I get another half. My brother gets another half. My dad gets another half. My mom gets half a piece, and my sister gets, oh yeah, that's 2½ that we just added up, and 5. Okay, so everybody gets a piece and a half. Essentially, we took 7½ pieces of candy, and we divided amongst 5 people, and each person got 1½ pieces of candy. Written another way, you could say this: 7½ pieces of candy divided amongst 5 people is 1½ piece per person. Well, that makes sense with the units. Okay, let's look at the next scenario. Let's say that night I ate 1/4 of a piece of candy, and then the next morning I ate 1/3 of a piece of candy. How much have I eaten? So I ate 1/4. Then I ate an additional 1/3. So how would I figure this out? Because these are different sizes of piece of candy. Well, let's try it a different way. If I break it up this way, let's say I ate 1/4 last night, so that would be this much candy. And then I ate 1/3 the next morning. Well, that would be this plus I already ate this chunk. So let's just move that here since I had already eaten this piece last night. Okay, well, in total, I can just count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So I've eaten 7 pieces in total out of 1, 2, 3, 4, 5, 6. So I've eaten 7/12 pieces of candy. Okay, well, that works. How much candy do I have left? Oh, we forgot to write this algebraically. So we have 1/3 plus 1/4 is 7/12. Well, clearly I didn't just add across the top, because 1 plus 1 is not going to give me 7. And 3 plus 4 is not going to give me 12. So we'll keep that in mind. How much candy do I have left now? Well, I did have 1 piece and a half, and I ate, so I'm taking away 7/12 pieces of candy. Well, I can see, let's see, I've got a piece and a half, and I'm eating some fraction of 12. So let's break apart my Hershey bars so we can see what all we've got. I have this full candy bar, I have half of this candy bar, and I've just eaten 7 12s. 1, 2, 3, 4, 5, 6, 7 of these pieces out of the 12. So how much do I have left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have left 11 12th pieces of candy. The whole point of this video is to think about when we need common denominators and why that makes sense. Let's look way back at the beginning. Examples 1 and 2 were multiplication. So I can see that even when I multiply by a fraction, 3 is a number of people, and 1/2 is a number of candy bars. So if I have 3 groups or 3 people who each get half a candy bar, then you end up with 1.5 candy bars. I didn't need common denominators to make sense of this. I was just counting them up or making groups. And when I divided, I was just splitting into groups, right? Again, this is the 7.5 represents a number of pieces of candy. The 5 represents a number of people. So I can split them up without needing a common denominator because the 7.5 and the 5 have totally different units. One is a number of people, one is a number of pieces of candy. But when I added and subtracted, it was hard to know the total number of pieces until my pieces were the same size. So when you're adding and subtracting, you need a common denominator because the numerator is telling you the number of pieces and the denominator gives you a sense of the size of each piece, right? How many pieces did I break the Hershey bar into in the first place to talk about how many of those pieces I ate and how many of those pieces I have left. Whereas when you're multiplying and dividing, one of the numbers is a number of groups and one of the numbers is an amount that goes into each group. So you don't need common denominators to multiply or divide. You do need common denominators to add or subtract.